This problem number 1 says that C is the concentration of a drug in the bloodstream at any time t in hours, and time t is when you actually administer the drug. So t is 0 is right when you take it, and C is the corresponding concentration, and the concentration depends on the time according to this set of instructions. And what we want to do is find the time when the concentration is at a maximum. So I'll write it here. We want to find the time to maximize the concentration. So we know how to maximize functions. We need the derivative. Now we're going to get C prime here, and it's a quotient, so I'll use the quotient rule. Here's the template: bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So let's see what we get here. C prime of t is the bottom quantity, t squared plus 16 times the derivative of the top, 100, minus the top, 100t times the derivative of the bottom, which is a 2t, all over that bottom squared. So all over the quantity t squared plus 16 squared. Let's simplify. So C prime of t is equal to, I'll distribute in, 100 t squared plus 1600 minus, looks like 200 t squared, all over that denominator, t squared plus 16 squared. So we'll simplify this. 100t squared minus 200t squared, that'll combine. So we will get C prime of t is equal to negative 100 t squared plus 1600 all over that denominator, t squared plus 16 squared. And now we ask those two questions. We really need to ask only one, because the second question is, where is it undefined? Where's the derivative undefined? Look at this denominator. It's never undefined, right? This will always be positive. Now, if it was a negative 16, we'd have to worry about 4 and 4, but it's not. So, question 1, where is C prime of t equal to 0? I'll do that up here at the top right. So C prime of t will equal 0 when, now, look, this C prime, it's a rational expression. Rational expressions, fractions, we know are 0 only if the numerator is 0. I don't need to worry about the denominator. I only have to worry about the numerator. So fractions are 0 only when the top is 0. So we'll get negative 100 t squared plus 1600 equals 0. Or how about 1600 equals 100 t squared. Well, I'll just add the negative 100 t squared. And now if I divide by 100, I'll get 16 equals t squared. So t must be 4 and negative 4 to solve the equation, but negative 4, of course. This is time since you took the particular drug, so we can't be negative. So we're going to say t equals 4. That's our critical value. So I'm thinking this is our only critical value. That's probably going to be where t is max, where C is max. So we got one critical value, t equals 4. It's probably going to be the case that 4 hours after you administer the drug, the concentration's at the maximum. But I'm going to prove this, just to be sure. So t, now, we have one critical value here at 4. So I'm going to analyze C prime at 4. Well, I'm going to analyze C prime in these intervals around 4. So first of all, what happens if you pick a number here, like 1? Just pick a number to the left of 4. It's easy to work with, 1. Now if I put 1, here's the derivative. If I put 1 down in here, what are we going to get? Well, I'll get 1 squared is 1. I'll get negative 100 plus 1600. That's positive. The bottom is squared. That's positive. So that division is positive. So this function is increasing, right? It's going up. Now, what happens to the right of 4? To the right of 4, pick a number like 5. Okay, I'll pick 5. So if I put 5 in here, I'll get 25. This will be negative 2500 plus 1600, right? 5 squared is 25, negative 2500, and then add 1600, it's still negative. So I'm getting a negative in the numerator. Bottom is positive because of that square. Whole thing is negative, so this function here is decreasing. It's going down. So we got increasing on the left, decreasing on the right. So this must be a relative maximum. And that is now proof that 4 hours will give us the maximum concentration.